Yes, it's really working. I'm cooling down my house in this heat wave with the groundwater that I normally use to just water my garden. It's about 12 degrees when it comes out of the ground. And I'm using the cold energy in it to cool down the house. And in this heat wave, this was the perfect moment to test it. Outside it hit 35, 37 degrees. And inside I'm now able to keep it at about 24 degrees. And there are many improvements that I want to make. And I'm making a bit of a shortcut here because I wanted to publish this part 3 earlier. But over the last days I worked a lot on improving the setup because of the heat wave. And I discovered so many things that I need to keep in mind, like the condensation on the floor, for example. And I have no clue how to explain it exactly because I need to learn way more about it. But it is working way more efficient than I expected. It's cooling down more than it should. Or at least I need to stabilize the cooling. I need to experiment with that. But it's working awesome. And that's why I really want to have this video, part 3, pushed online as soon as possible, so that you can already see what is working, how it is working, and that you can discuss or that you can just give me feedback what you think about it. So I'll go quickly through the setup and then we go as soon as possible to the results over the last days. I gathered some measurements and some graphs that I want to show you and that show how it is exactly cooling. So this was my original setup with the Heatwave pumps, but because they gave too much flow, I went to this small 12-volt brushless pump. It's giving about 4 liters an hour, which is at this moment quite efficient or quite optimal to have a good cooling, to have a good heat transfer on the heat exchanger that is changing the cold energy with my floor cooling circuit. And that's my buffer reservoir. And at this moment, to keep it as simple as possible, I use my groundwater pump to fill it with about 250, 300 liters. And then I'll flow that directly through the heat exchanger with a flow rate of about 4 liters per minute. And I'll just flood it on the garden, which otherwise also would happen. But I want to make it more efficient by buffering it first and then have it spread it like in a better way, like in a more efficient way over the complete lawn instead of just one place. But as for now, this works really well as a test setup to prove that the concept is working. So I'll show you a little bit more about the setup, the installation itself, the parts, the components, and then we'll go to the results, the measurements over the last days. And I'm really impressed. And this video became way longer than I had in mind. But I really wanted to explain a lot about the details, the measurements that I've done over the last days and the challenges that I found. And there are way more, but I will work on that in phase 4. So let's go to the parts and the setup. So the project is far from finished. I need to relocate some temperature sensors. I need to install flow sensors so that we can calculate the actual energy transfer. It looks like that there is like more cooling taking place than I want. The pipes are getting colder, giving me a lot of condensation. That's something that I really want to prevent. So I need to reduce the flow there. In this part I'll show you the first results over the last days. And they are quite impressive. And if you didn't saw the previous parts, I would highly recommend to check them. In the first part, I'm testing the proof of concept, just laying on the table outside, connecting it to some pumps and the heat exchanger. In the second part, I really installed everything in the house. I connected the heat exchanger to my floor heating system, an additional circulation pump, and all the connectors that were necessary to make it a good setup. And in this part 3, I'll show you the first real-world results. The parts that I ordered and the additional ideas that I have to make the setup more stable, more controllable, and that we have clear insight in exactly what is happening in the energy transfer and how much potential there is more in this concept. And I guess you recognize my enthusiasm for this. I really like this project. The results are so good so far, and there is still so much potential to improve and to automate things that I'm really looking forward to continue with it. I'm waiting for the parts to arrive this week. And after that, I will make a next part where I'm installing all those things and where we do the first step for automating. But first, I'll guide you through everything that happened over the last days. And those are some interesting things to explain already, because I tested with several pumps. I had those vapor pumps laying around and I ordered one additional for this project. But they give quite a lot of flow and they consume a lot of energy. So I was searching for a pump that suits better this project. In the final setup, I'm thinking about a PWM controllable pump so that I can control the flow quite accurate. But for now I'm using this small 12 volt DC pump, and it's consuming about like 10 watts of power, and it gives a flow of about 4 liters per minute. And by having a limited flow on the groundwater circuit, I'm able to impact the temperature that goes to the floor. Because if the flow on the groundwater side is too high, the temperature to the floor lowers to about 15 degrees, which gives condensation. And with this lower flow, I'm able to have a temperature of about 17 degrees to the floor, which is way better. And of course, it's really hard to say how much energy there is transferred. As for now, I'm using the buffer, where I have the groundwater of like 12, 13 degrees. And I'm using that through the heat exchanger, and now it goes directly to the garden. This is one of the ideas. The other idea is to circulate it in the buffer and then see how that behaves. And the final thought is to have the buffer also connected to the groundwater pump instead of the groundwater itself, so that the buffer can be emptied to the garden via the same groundwater pump. And if you like the banana trees around my setup, that's also something that I'm really passionate about. I made a video about how to revive your banana plants in the Netherlands after the winter. Because sometimes it's quite challenging, and I'm trying to figure out what gives them the best chance to grow back after snow in the winter. And how easy is it to let them survive inside during the winter? Okay, let's go back to the main topic of this video, the groundwater cooling. So this is what the outside setup looks like right now. As you can see, it's still very much a prototype. It's not pretty, it's not optimized, and it's definitely not the final version I have in mind. But hey, it works. Inside this black wooden enclosure is my groundwater pump. Earlier in this project I tested this system by pumping groundwater directly through the heat exchanger. And technically that worked, but it also caused the first failure of this project. The pump was switching on and off every few minutes to maintain a low and constant flow. Even though it wasn't cycling excessively, the capacitor inside the pump eventually failed and had to be replaced. Next to it you can see my bench power supply. I'm currently using that to control the flow rate of this small 12 volt brushless low power pump. At first I experimented with those larger pumps, but they produced more flow than I really needed for this test setup, which resulted in a too low temperature to the floor. So I switched to this smaller one. It consumes only a small amount of power, but still provides enough flow to transport the cold energy from the buffer tank to the heat exchanger. As for the hoses, well, this is one of those situations where I simply use the materials I already had available. It may not win any beauty contest, but it's getting the job done here. The small garden hose is carrying the cold water towards the heat exchanger inside the house. The larger yellow hose is the return line. And yes, both hoses currently enter the house through my bathroom window. I would not recommend doing that. And I have to admit, it still makes me slightly nervous knowing that cold water is being pumped through temporary connections inside the house. You can also immediately see one of the biggest weaknesses of my current setup. This garden hose is relatively thin and it's exposed to direct sunlight. That means that some of the cold energy is already being lost before the water even reaches the heat exchanger. For a temporary test setup that's acceptable, but it's definitely something that will be improved in the next phase of the project. Right now I'm using this reservoir as a cold buffer. I'll fill it up in about 15 minutes with roughly 700 liters of cold groundwater. And after that the small pump slowly extracts the cold energy at a flow rate of about 4 liters per minute. At that flow rate the system can run for almost 3 hours before the entire content of the reservoir have passed through the heat exchanger. And that brings us to the next obvious improvement. This is simply an open reservoir sitting outside. As a result, it continuously exchanges heat with the environment. The longer the water remains inside the buffer, the more cold energy is lost to the surroundings. For this proof of concept setup, I'm willing to accept that inefficiency. But in a future version, I'm considering burying the reservoir underground, where the surrounding soil would provide natural insulation and helps preserve the cold energy for much longer. So this setup may look like rough around the edges, but it already allows me to test the core ID. And now let's have a look what's happening inside the house. So this is the inside part of the setup where the hoses enter the house. The small hose is the supply line bringing cold water to the heat exchanger, and the yellow hose is the return line going back outside. And for now I'm using the opening in the ceiling where the ventilation duct normally runs. It gave me an easy temporary route to reach the heat exchanger in the attic. And this is the actual cooling setup which I explained in more detail in the previous video. What is worth mentioning now are the things I discovered during the first days of real cooling. To get some insight in what is happening, I installed temperature sensors directly onto the pipes. They show me the supply and return temperature of the floor cooling circuit. This tells me exactly how much the water is warming up while it moves through the floor. On the groundwater side of the heat exchanger, I don't have proper temperature sensors directly on the pipes. For now I measure the temperature outside in the buffer tank and in the return hose. That's something I will improve in the coming days for the next part of this project. One of the important issues you can already see here is condensation. At first I was sending water at around 15 degrees Celsius through the floor circuit. That made the pipes cold enough to create a lot of condensation. For the first day of testing I accepted that and kept a close eye on it to make sure it did not become a problem. But after that first test I reduced the groundwater flow. That brought the floor supply temperature up to around 17 to 18 degrees Celsius. It still creates some condensation, but much less than before. So there are two clear improvements to make here: insulating these pipes and making the supply temperature more controllable. But for this first prototype test, it is manageable. I think I talked enough about the pipes, pumps, temporary solutions. Let's move to the interesting part, the actual results. So these are the results. This is how the system is running at this moment. And I made a simple dashboard to give myself some insight in what is happening while the system is cooling the house. It was around 32 degrees Celsius earlier today, but it already cooled down a little now, so it's still about 29 degrees outside. Inside the house the temperature is staying much more comfortable than it normally would during those conditions. Without cooling, the house can easily reach around 28 or 29 degrees indoors on those hot days. So even before looking at the technical details, the main result is already clear. The house is staying significantly cooler. Below that you see the overview of the floor cooling system. There are quite a few numbers on the screen, but I want to spend a little more time on them on purpose, because this is where the real potential of the concept becomes visible. On the groundwater side, the small low power pump is currently using around 14 watts. It is slowly moving groundwater from the buffer tank towards the heat exchanger. And I don't have proper temperature sensors directly on both of the groundwater pipes at the heat exchanger, so those values are not shown here. For now I measure the groundwater temperature outside in the buffer tank and in the return line. The groundwater entering the system is roughly around 12 to 13 degrees Celsius, so that's the cold energy source feeding the whole system. On the floor side, the water is currently entering the floor at around 70 degrees Celsius, and passing through the floor it comes back at around 20 degrees. And on the screen you see the exact delta, the difference between the inflow and the outflow, which is about 2-3 degrees. And later I will show some graphs, how this is throughout the day, and that's even more interesting. This is actually a very nice result, especially because the system has already been running for quite some time and the floor has already cooled down significantly. I measured the floor today and it was about 20 degrees, 21. On some places where there is a smaller loop in the floor, it was about 19.5. And that we see this change between the inflow and the outflow means that the floor is still absorbing heat from the house and transferring the heat back into the water. And that's exactly what I wanted to prove with this concept. The floor is not just getting hot because I'm pumping cold water through it. It is actually removing heat from the building. The temperature difference is also not constant. Yesterday evening and during the night, when the floor still contained much more heat, the temperature difference between the water entering and leaving the floor was even larger. At one point the difference was more than 3 degrees Celsius. But I think this is the best comparison that I can give. This is the behavior of the house during high temperatures without cooling. So this was May 25 this year, and we start with like an outdoor temperature of about 30 degrees. At that moment the house was also about 27. Now during the night it cooled down. It really cooled down to about 14 degrees, so that was a really good moment to ventilate, and I guess that didn't happen. That's, by the way, another project, my heat recovery unit. I'm also working on optimizing that. This is really nice data to optimize my heat recovery unit even further. But let's stick to this example. So the house stayed quite hot, as you see, about 20-25 degrees. And the next morning at 10 a.m., the temperature outside went to 33 degrees again. Inside the house it was 27. Then in the night it went down again to like the night temperatures of about 16 degrees, and the house stayed hot at about 27 degrees. The next day you see again the outdoor temperature is 28 and the inside temperature is 27. And now looking back at today, I think you understand why I'm so impressed about this. With the temperatures of about 30 degrees outside, I was able to have my living room at 22 degrees. And at the end it was still about 24 in my living room. But that was also because the buffer heated up. It was not filled with the 13 degrees groundwater anymore. And now looking at the last days, this is just my proof of concept. There are many things to improve. And I'm now already able to realize a comfortable living climate, a comfortable temperature in the house throughout the days. And for those who are interested in the temperatures throughout the days, if I'm looking at the delta, the difference between the inflow and the outflow, let me show that on a smaller time frame. So this was the temperature difference between the inflow and the outflow from like yesterday evening until this evening. And we see that it was sometimes around like 3 degrees, 3.6 degrees. And on general, it's about 2. And here we see that it really went down. And I think this is because the water outside is going through the small garden hose. It's already losing quite a lot of its cooling capacity there. And this, we can ignore this. There I was playing a bit with the reservoir and with the pump, so ignore this. After those adjustments, we went back to like almost 3 degrees delta. Those are also interesting to see. Those dips, we can easily explain them because there is fresh groundwater flooded into the buffer. So every 30 minutes there is new groundwater filled, pumped in the buffer. So that made that there is new supply of cold water, which gave more cold energy transfer to the floor heating, of course, floor cooling in this case. And the graph that I just showed with the delta, it's the result of those two temperatures, the inflow and the outflow of the floor heating circuit, floor cooling circuit. And we see that it went down over time. And here we see that the groundwater pump is now filling up the reservoir. That's also like every 30 minutes, it's running for 4 minutes to fill up the buffer. And looking at the complete power use to cool down the house during like one day, 24 hours, I calculated that it is about 4 kilowatt hour. So I think that's also really impressive, looking at the cooling capacity that I have for 4 kilowatt hours. And there are quite some efficiency improvements to make there. I think that's enough about the details behind the data of this experiment. If you have questions about this, then let me know. If you have an idea that I'm doing something wrong, let me know as well. As already said in the earlier videos, I searched around and I was not able to find anyone who was using groundwater in this way to cool his house. So I thought, will this ever work? But now it's really working in my house and it's giving me so impressive results. This is not a simple setup, but it's also not complicated. If I can fully automate this, then there is almost no manual control involved. Then everything will run automatically. And based on thresholds that I set, everything will run by itself and it will cool down my house for like a little bit of electricity, and the water, the cold energy in the water, that is already used to water the garden. So let's evaluate where we are right now with the groundwater floor cooling project. This became a much longer video than I originally had in mind, but I think it was worth spending the extra time on the measurements and the results. In the end, that's really the only way to prove that a concept like this is working. And as I already mentioned, there are still quite a few improvements that I want to make. I want to add flow meters, more temperature sensors and gather enough data so that we can do proper calculations about the cooling power and the overall efficiency. But for now, I'm really impressed by the results. Over the last days, I've been able to keep the house comfortable by using only a little amount of energy. And I think there is still a lot of room for improvement. I'm currently waiting for some more parts to arrive. And when they do, I will work on the next phase of this project. What impresses me most is when an idea moves from something that's just in my head to something that actually works in the real world. And this project definitely did that. I hope you're just as impressed about the results as I am. And if you have any thoughts about this project or my concept, then feel free to leave them in the comments or get in touch. And if you like this project or the things that I'm working on, then support me by becoming a subscriber and help me grow the channel. There are several videos about energy efficiency on the channel, but also completely different projects. Maybe you're interested in the banana trees you see around me. Or maybe you're wondering why my lawn is in such a nice condition. If so, take a look at the video about scarifying your lawn. That was another project where I simply had an idea, became curious about the outcome and documented the process. These are all projects that I really enjoy creating and sharing. For now, that concludes this part of the project. This was Forest Guy Builds. I'm John and I hope to see you in part 4, where we'll find out how far we can push this system.